Today we are going to learn about coin combination 1. Okay, right. So consider a money system consisting of n coins. Each coin has a positive integer value. Okay, your task is to calculate the number of distinct ways you can produce a money sum x using the available coin. For example, if coins are 2, 3, 5 and the desired sum is 9, there are 8 ways. Okay, that is 2 plus 2 plus 5, 2 plus 5 plus 2, 5 plus 2 plus 2, 3 plus 3 plus 3. Okay. So n and x, the number of coins, the desired sum of money, second n distinct integers c1 to cn, the value of each coin, and we have to print one integer, the number of ways modulus 10 to the power 9 plus 7, and these are constraint. So in the question it is stated that we have to consider 2 plus 5 and 2 plus 5 plus 2 as different. Okay, so we'll move, and it can be resolved with one DDP. Let's say I have to calculate f of x, right? And let's say I know everything before x. X is what? The desired money sum, right? So we know all from x minus that to that. So to create f of x, I'll either add at the end to whatever value would we have. Similarly, at the end of 3 and at the end of 5, right? Means at the end of 2 means x minus 2, x minus 3, x minus 5, right? So if I'm adding x minus 2, that let's say a, this is b, this is c, so answer would be a plus b plus c mod modulus, whatever our modulus is, right? So again, so we'll have, when let's say x equal to 0, that is we'll have one way to create that coin, that is we don't take any coin, right? If I have to create one, let's say in this case I don't have any way to create one, since I don't have any coin with 1, so that would be 0. If I talk about x equal to 2, I'll have 2 to create 2. If I talk about 3, then I'll have what? That is 3 itself. That is, I'm only taking 3 coin, right? Because there's no way we can create it 2. And x equal to 4, that is 2 plus 2. When I talk about x equal to 5, right, that is, now we'll have 5 minus 2 and 5 minus 3, right? So we'll take from this and we'll take from this, so that is 2 plus 3 and 3 plus 2, right? So whatever we have calculated earlier, everything, right? For this is what f of 2, this is what f of 3, so f of 2 plus 3 we are doing, so that is what we are adding one coin to it. So that is one way, this is one way, right? So 1 plus 1 would be 2, so we'll have 2 ways to obtain this. Similarly, we can go and create till f of 9. Now we'll see the implementation part. So we have written the code in C++. We have taken n and x as our input. In this line we have set our modulus 10 to the power 9 plus 7. This is how 1e9 plus 7 you say it in C++. We are taking input in coin array or vector, we are calling it vector, and this is our dp to store all the sum prior to x, right? And we are starting from 0, that's why we are taking from till x plus 1, so that we can store everything from 0 to x, and the size of this would be x plus 1, 1 to x and 0 including, so x plus 1. We discussed that dp of 0 equal to 1 because when we are creating 0 we don't need any coin, that is one way. So we have taken input, right, coin for. Then we are traversing to amount. We are going to each amount that we discussed, like 1 0 1 2 3 0 we have already filled, so we started from 1 and we'll going till x, increasing 1. And then we have traversed to the coin array, right? Like we discussed, we are checking if it is possible for that coin to get added to some number, right? And since we started the dp of all elements with 0, right? So let's say I'm not possible to make one, right? Like we saw in the case when 2 3 5 are the coins available, so you won't be able to make one, right? So that would be always 0. Wait, so let's say I have to make 4 coins, so 4 minus 3 would be 1, right? So whatever number of ways 1 I can create, I'll add 3 to that, will get 4 means the value 4. So since that is 0, so that would be always will add only 0 for that prospect, right? So we are on the right track. So we are just adding it, we are doing modulus at each step. Since we know the concept of modulus, that a mod equal to a mod plus b mod whole mod is equal to a plus b mod, right? That's what we are doing. So that's at the end we are printing our required sum, that is dp of x. Either we are not able to make, that is, let's say for 1 somebody would ask x equal to 1, then it would be 0 in this case. But if somebody would have asked for 9, then there are 8 possible ways. So we'll execute our code. So our input case was, okay, we were having size of 3 array, we were trying to make some 9, and we have 2 3 and 5 as a coin. So we are able to execute it and we got 8 as an answer, so that's what it was expected. Now we'll try another test case that we discussed. Let's say for the same case we need now sum is 1. So with 2 3 and 5, when we execute it, we should get 7, we are getting it 0, right? That's what we expected. So this is the required answer.